All right, time for another draftphysics.com, debatephysics.com also, but we really can't get any of these people to actually debate any of these subjects, so that's disappointing. So we just have to do our part, and we will, of pointing out how, you're not doing the world a favor by preaching, okay, a fake, phony, fable narrative, okay? Something just totally made up that isn't supported by really any good evidence and has a terrible history. And if you paid any attention at all, you'd notice that and you'd be a little disturbed that you are preaching garbage. But they won't do that. Unfortunately, they won't deal with the facts, the evidence, the real circumstances, the truth. The truth is obnoxious to people calling them scientists. They have a doctor in being a scientist. And they, frankly, in my opinion, suck at it because they don't understand that the first thing you want to do is do no harm, that is, preach no falsehoods. It's really important. So anyway, this is on energy. I've tried to contact this Parth guy before. It hasn't worked, so blah, 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 blah. And he's currently on hiatus making music or something. This is a fascination among physicists I don't fully understand, but whatever.
Hey you lot, Parth here, and in this video we'll be looking at kinetic energy, a very important concept in physics.
So energy is the only word that's important, okay? And the concept is, as Descartes kind of put it, is there's a certain amount of this quantity of motion, this movement in the universe. And the movement can be in tiny discrete form of the elemental speed of light force, or it can be in something obvious like a big elephant that's moving. And that energy doesn't stop or disappear. It always has to go somewhere else in its lifetime. It doesn't end. It's forever. And that's a key concept. That the point is that the stuff hits you like wind. It blows on you, okay? But it doesn't cease to exist as motion in the universe. You have the motion and then you hit something and you move other stuff and the motion just continues to move. And the point is that, yes, from our perspective, it looks like the energy dies when it turns into heat or it turns into some discrete motion that we can't follow anymore. But it's still there and it's still going to do work in the universe forever.
In 5 levels of difficulty.
So in the first level, he doesn't bother with the history. He doesn't bother really explaining the concept of this conservational thing, which is the most important words you can utter regarding what energy is. And the fact that it's really just anything, the force or the matter moving. That's energy. Something moving. And the point is the moving is a relative thing. I can be standing still and the force can be moving, or I can be moving and the force can be non-existent, so to speak, and I'm just going to be pushing on it instead of it pushing on me. And so the key concept is that energy makes exchanges. Every time something moving, if it doesn't have contact with something, it can't exchange. So the idea is it has to contact something. When two things contact each other, they'll just exchange their conditions. And the longer they have contact, the more they can exchange. The less contact, less time, the less they exchange. You can make it that simple.
If you're new to the idea, then feel free to watch the whole video. If you already know a bit about kinetic energy, then feel free to skip to the bits that are new to you using the timestamps at the bottom.
Whatever. So we're supposed to know what you're exactly, whether you said anything brilliant or not and all the other stuff. So yeah, that's kind of bullshit anyway, but whatever. I think they could stand the 12 minutes.
If you enjoyed this video, then please hit the thumbs up button and subscribe for more fun physics content.
Okay, this idea of fun is just so irritating too. It's serious, frankly. You're telling, your story is about the truth. Okay, it's supposed to have integrity. It's not supposed to be fun.
Also, if you'd like to see more of these 5 levels of difficulty explanations.
No, I don't even know why anybody would want to see any of it. There's only one truth, okay, and it should be explainable to a 5-year-old or a 50-year-old. And yes, details, the more complicated you want to get, that's reasonable, I suppose. But then you're just sort of just saying, you want to know how to play chess, or do you want to know how to win, playing a master at chess? Obviously, it's going to take a lot more time to be a master.
Then let me know what topics to cover.
But in 12 minutes, I don't think you can do a master's on energy. So 5 levels in 12 minutes? I don't think so.
Now, though, let's talk about kinetic energy. Let's start.
So let's just talk about what energy. This whole kinetic nonsense is just such a nonsense to put the word kinetic in front of it. I could just say momentum energy, and what do and that's the real point, is that you have two ideas of what energy is, one written by Newton, MV, and one written by Huygens and Leibniz, MV squared. And they're fundamentally different definitions, and you really do have to choose one or the other. You can't pretend there's a third law of energy if you believe in kinetic energy, because it never obeys the third law.
Start with level 1. What is kinetic energy? To answer this question, we can first briefly talk about what energy is, and then what specifically kinetic energy is.
So you're just going to tell us, okay, but the point that I would argue is energy is just motion. And so you can't have motion go in, 100 motions, 100 quantity of motions, momentums, and then get 300 out. Because motion can't multiply. You can't make free motion.
Energy is basically a number or a quantity that we can assign to anything we happen to be studying.
Right, and again, it all has to be understood in the context of the fact that we are in relative conditions. And so it's hard to know who's doing the absolute thing. Finding an absolute place, a lighthouse of absolute motion, we don't have, except for photons, for example. But anyway, we don't have that. And so you do have to understand that, sometimes, depending on your circumstance, like rotating on the Earth and moving on the Earth around the sun, that you have motion, and that what you really could be doing is losing your motion when you think you're gaining energy. You're actually losing energy, but relative to everything else.
Which tells us something about how it is behaving or how it will behave.
So it's only behaving when it interacts with something. So again, the key point is what it's interacting with. And it's just the relative difference between the two things that are interacting that will be significant in defining how much energy there is. So it's just about a thing compared to something else. The atmosphere and us. We can use the atmosphere as being something not moving, and then compare everything else moving by relative comparison. Sort of an important concept you got to do right away is understanding that you're not defining an absolute value, you're defining a relative condition between the meeting of two things.
We can look at how energy is transferred between objects, or
so both of these objects could be going 5,000 miles an hour in that direction. And so one of them didn't really go backwards. It just is going 495 instead of, that kind of thing.
Or from one type of energy to another, which allows us to mathematically predict how the thing that we're studying will act at some point.
So all of this is hilarious because the predictions are terrible. You don't conserve the kinetic energy in most all of these collisions between uneven masses. So what's the predictive value of something where it says there's twice as much energy and there isn't? So what's the point? Your predictions are way off. Your prediction says an 8-pound bowling ball going 16 has twice the energy of a 16-pound ball going 8. Yet if I put them in a tug of war, there's going to be no evidence. And if I go knock down pins, the pins are just going to collect momentum. I mean, Parth, can you appreciate that if you are completely wrong, okay, if the theory is completely wrong, it's a pretty important, that you're saying something has twice the energy when the evidence says it's not even close. It's non-existent. You can't collect it. You can't diagram for me how the kinetic energy gets into the pins in any other form than momentum. The ball hits the pins, you calculate how the velocity of the ball, it gives the pin that much velocity, and the ball loses exactly what it gives away in terms of momentum. There's no room for kinetic energy anywhere in the equation, and that's why professional bowlers aren't using 8-pound bowling balls. I mean, again, I have to say this over and over. It doesn't bother you that you're claiming that a 5 mass going 10 velocity has twice the energy of a 10 mass going 5 velocity. It's absolutely not true. You're preaching it as a truth and giving me 5 levels of difficulty in terms of understanding reality, and you can't even get that right. I mean, I'm not allowed to say that's pretty pathetic for a scientist that spent years acquiring this knowledge, and it's got flaws in it that gaping. You're going to tell me that you're going to accurately predict something when you can't accurately predict it, when you claim things. You're claiming that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet in gravity. Well, it drops the 4 feet in 2 units of time. It's a time-dependent force. It's only 9.8 meters per 1 second. It's only 2 seconds. It's only twice the velocity, twice the time, twice the velocity, twice the weight. It's twice the energy. Not 4 times the energy.
Point in time in the future. And kinetic energy is the energy that an object has when it is moving.
So everything, all energy is the energy it has when moving. So momentum is exactly the same thing. Yes, you have momentum when you're a mass moving. MV. I mean, it's just so annoying that this kinetic energy thing is based on momentum. Momentum comes first. You have to have the M and the V before you can do the silly thing of squaring the velocity. But why would you square it? Why would you square a velocity? As if a velocity can be anything other than a one-dimensional line.
In fact, kinetic energy directly depends on how fast the object is moving.
So again, and so where's the scalar part of it? So he says speed. Okay, so the kinetic energy is the speed, the unknown speed. It has speed in no direction. Yes, that's a scalar. Speed in no direction. I mean, it doesn't make any sense. You can't even just smell how that doesn't make any sense to sit there and use the word scalar and say there's such a thing as a speed without any direction. What's the point of talking this way? I just don't understand why all you people defend this kind of mush. A speed with no direction. I mean, what is that? Oh, yeah, it's no better than a bent space, frankly.
It's speed. The faster an object moves,
the faster it moves where? How, if it's got no direction, how could it be moving somewhere if it has no direction? If its speed is directionless. Oh, it's just such nonsense.
more kinetic energy it has. But if it's stationary or not moving, then it has no kinetic energy.
So obviously that's what's under dispute, is the fact that anything that we know of anyway has an absolutely no movement. So that's the trick, is that we don't have that thing in the universe to, to compare everything else to. But that concept was clear to Newton, that that thing does actually exist, that there's no reason we can't create such a thing, okay? Because the universe is just 3 dimensions of space, and there's just distance between objects, and there's a limitation to how fast they can interact.
It's also worth mentioning here that kinetic energy, just like other forms of energy,
whatever the other forms are. So again, you can understand that if I say momentum, it's momentum of an electron, momentum of an atom, momentum of a compound, momentum of all things have momentum, and it's one thing. So heat is momentum. Photons are momentum. Everything is momentum. All right, because everything has got a, you can't interact with something if you don't have a mass at a velocity. So again, they'll say that photons are massless. They just say it. It's just a statement they make, like they've declared it to be true. They have no frickin' evidence that it's true. Zero. There's no experiment that shows photons don't have mass.
Is measured in joules.
And that's another concoction. Okay, so instead of just leaving it the way it was, measuring it in foot-pounds, measuring it based on its weight. That all impacts really are, you're just measuring weights. It's just momentum. Momentum is a weight. I turn the scale. I mean, come on, Parth. You can really get this, right? There's nothing fundamentally different between gravity pushing something into a scale, okay, and me pushing something into a scale. Motion this way is the same thing as motion this way, okay? The force is the same. So it's just about a momentum. Gravity gives you momentum. This is your momentum. I can duplicate that by just making you move 1 mile an hour into the scale, and you will read your weight. Yeah. It's weight. It's pressure. That's all there is. Contact creates pressure. Pressure is always goes from high pressure to low pressure, right? So it's a pretty big, easy solution. The relative pressures are just compared and exchanged. And again, the better the contact, the more time the contact takes over, the more capacity there is for there to be a complete exchange, and both objects will become the same speed.
Which is the standard SI unit for energy. Level 2. So it's all well and good saying that...
So in level 1 we didn't get that. The whole thing was just stated by Leibniz 350 years ago with the axiom 4 pounds dropped 1 foot, same as 1 pound dropped 4 feet. Never shown to be true. No experimental evidence. Zero. And then de Châtelet came around in 1735 or whatever, and tutored by a Leibnizian, and she propagandized the subject with rigged gimmick experiments, dropping round things, denting clay with round objects. Not a linear test of energy. Really flawed experiments, and that's it. There's nothing. There's no proof of this nonsense. They never sat there and took the 5 mass going 10 and the 10 mass going 5, tied a string between them, and saw which one has more energy. When the fact is, obviously, they have the same energy.
Moving object has kinetic energy. But exactly how much kinetic energy does it have? Well, there's a convenient equation that tells us exactly this.
Convenient to who? How is it convenient? All it does is create fake notions of reality. It doesn't lift rockets off the ground, so the kinetic energy of the thrust will be some preposterous number, 200 million joules or something. And the rocket motion will not be 200 million joules. It will not be an equal and opposite reaction to the kinetic energy. The momentum number will be something reasonable, like 20,000 pounds. And there will be exactly the same motion in the rocket as if it had been hit with 20,000 pounds of energy, force. So momentum completely gets right answers, completely solves the problem. It will accurately land you on the moon. Kinetic energy, if we're obedient to it, all right, would crash you on the moon. Just a fact. You can't collect the kinetic energy in a ballistic pendulum. The bullet is supposed to have 2,000 joules. You collect 0.06. That's it. You collect a portion of the momentum. You don't even collect all the momentum because it's hard to collect the energy from a bullet. But you collect substantially 80%, 85% of the energy of the momentum, and you only collect 0.06 of the kinetic energy. It clearly doesn't exist. It's a fable. It never does work.
The kinetic energy of an object that has mass m and is moving with a speed v is equal to 1/2 mv squared.
And it's a fable. Again, never proven with physical evidence, credible physical evidence. Never proven by showing 5 mass going 10, 10 mass going 5, tie string between them. Does the 5 mass that has twice the kinetic energy, double, twice as much energy, does it pull? Does it win the tug of war? No. Twice the energy, yet it can't win the tug of war. And then again, a lever proves all of this to be nonsense. So a balance tells you what equals what. All right, and the balance says kinetic energy. Can't see it, can't find it. The balance says momentum wins.
So let's break this equation down. Let's say we have a wooden block with a mass of 1.
He's not going to break it down. He's just going to sit there and use it and make up fake lies about what the truth is. So he's going to tell us that the 5-ton going 10 is the same as is twice as much energy as the 10-ton going 5, and I need a 20-ton going 5 to have the same amount of energy as the 5-ton. Nonsense, absolute nonsense. And he's going to tell us right now that that's the absolute truth. But he won't show me an experiment where he demonstrates that to be the absolute truth.
Kilogram. And initially, it's stationary. In other words, it's moving with the speed of 0, or it's not moving. In this case, the block has no kinetic energy, just as we expect. Now let's say that it moves at a speed of 1 meter per second. At this point, the kinetic energy of the block is 1/2 joules. Now, because the kinetic energy equation has a factor of speed squared, we see something rather interesting. If we double the speed of the block to 2 meters per second, the kinetic energy increases by 2 squared times. It becomes 4 times larger.
Right, and if we make 3 times, it becomes 9 times larger. If we make it 4 times the velocity, it becomes 16 times larger. And if we make it 5 times the velocity, it's 25 times the fuel to go 5 times as fast. A ludicrous idea. Doesn't show up anywhere. Water wheels, spinning things, doesn't matter what you bring up. It never is true. It never takes 25 times the fuel to move something 5 times as fast. It's a ludicrous statement. Nobody reasonable who's touched anything mechanical in their life could absolutely believe it, because there's just no evidence that it's true. And yet you're preaching it. I mean, it's disgusting. Sorry, it's disgusting. It's so wrong.
So changing the speed of an object has a big impact on its kinetic energy.
Which is, again, absolute nonsense. The bullet has 2,000 joules. The gun recoil is 2. 1,000 times difference in the amount of claimed energy. But if I try to collect it, if I try to do work with either one of those things, I'm not going to be able to do more work with the bullet. It's not going to knock down building. It's not going to do a better job of knocking down a building than the wrecking ball, the big, giant, heavy, slow thing. So again, it's just nonsense that kinetic energy does anything, ever.
But in this equation, there is another factor that contributes to the kinetic energy of our object, the object's mass. If we now think about a second block traveling at exactly the same speed as the first, but with half the mass, then this second block will have half the kinetic energy of the first block.
Right, and it'd have half the momentum too, right, because you're not changing, by changing the mass, okay, you're not changing something that has a squared function. It's only when you change the thing with the square on it that you're going to run into big problems.
Incidentally, this is why a big truck or lorry traveling at the same speed as a small car is more dangerous.
Right, and so why don't you do the reverse circumstance, where you just have the difference in their huge, I mean, you really can't have the same mass, right? The car, what's the point? I mean, obviously, so the point is that if you give the car a faster velocity, you'll start claiming it'll do more damage than the truck. You'll start claiming that it has more energy than the truck, when it's not going to be able to overcome the fact that the truck will always have, until you go really, really fast, more momentum. I mean, and again, you're doing this in the face of Newton, where you're basically just spitting on Newton's 3 laws and saying they don't have any relevance.
It has more mass and therefore more kinetic energy to transfer if it were to crash into something. Now, there are a couple of things.
So obviously, if they're going the same speed, so just change the speeds and all of a sudden you'll start saying things that just aren't true. So I just have to double the car's speed and that'll quadruple its energy. And so now that car of 1/4 of the mass you're going to claim is going to be able to do more work, and it won't. The 8-pound bowling ball going 16 does not do more work than the 16-pound ball going 8. No evidence whatsoever anywhere on this planet that that crap is true.
To note here. Firstly, that v represents the speed of the object, which is a scalar quantity.
So again, more baby talk. Okay, speed, not velocity. I mean, what the fuck? This is science? You're going to play a game like this and you're going to say that, you know, I don't know what, black isn't dark? Let's say, I mean, they couldn't be, the two words couldn't be more interchangeable, speed and velocity. I mean, they're the same word. Might be, you know, they might be in the dictionary under perfect synonym, speed and velocity. They're perfectly replaceable with each other. And you're just playing some game that there's this magical way that something goes a distance in a certain amount of time, but it doesn't do it. It doesn't actually go in a direction. Nonsense.
And not its velocity, which is a vector. In other words, our block moving in this direction at 2 meters per second has the same kinetic energy as the same block moving in any other direction at 2 meters per second.
Well, obviously, you know, that's the whole point. Because there's no such thing as a negative direction for energy. There's no such thing as me breaking something into two pieces, right? I hit it this way like a pool ball or something, and they fly off in these directions. That somehow, because these two directions cancel, I can put an infinite amount of energy in there. What the hell are you talking about? The energy doesn't cancel. I only have so much energy going in. I only have so much energy to push things apart with. And that's all there is. 100 momentums go in, 100 momentums come out. It's never 100 goes in and 300 comes out. It's nonsense.
What matters is the speed, not the direction. Secondly,
I mean, just too ridiculous that you could have speed without a direction. I mean, again, look at it. You know, he's got a smile on his face while he says something that ludicrous and silly. I have to I'll take a pause. I mean, I mean, why would rational people say this is okay? You can talk absolute wacky nonsense like this. That somehow you have a speed without a direction. What a pile of crap. Alright, I'm back. I hate this planet.
There's this factor of 1/2. Why is it there? Why is the kinetic energy 1/2 mv squared rather than just
because that's what your joule demands. Yeah, that's you know, because of the unit you've decided on.
mv squared or something? Luckily, we'll see one reason for the 1/2 being there in level 4 of this video.
Yeah, whatever. And it's a non-reason.
For now though, let's move on to the next level. Level 3. If you're familiar with the idea of reference frames, then this next thought might have occurred to you at some point during the first 2 levels. When we talk about kinetic energy...
So it has nothing to do with a reference frame. It just has to do with the fact that things have relative motions in the universe, and everything has a motion in an absolute sense, and then they have shared motions. We're stuck on this planet. Everything is moving the same. It's all been given the same velocity, like in a car or something. And so, yeah, you're going to have a relative condition, and that's it. But there's no frame.
We always mention the speed of the object, but it's worth remembering that the speed is always measured relative to something. In other words,
so the velocity has to be relative to something because the velocity has a direction. So I don't know why he's talking about speed again, but whatever.
When we say an object is moving at 2 meters per second, what we usually mean is that it's moving 2 meters away from some point on the ground every second.
Right, or relative to the thing it's going to hit. You know, you don't have to necessarily have any universal reference point. You just have 2 objects moving in space, and the 2 objects, you know, have emotions in conflict. That's why they're going to hit each other, is because their motions are in conflict.
In essence, the object is moving at 2 meters per second relative to the Earth. But let's imagine we're now on a different planet, let's say Mars, and we see the Earth moving this way. Let's ignore the rotation of the Earth just to keep things super simple. I know this is a bit strange, but run with me here. Let's also imagine that we somehow spot the object that we're considering on Earth, and it so happens to be moving at the same speed relative to Earth
as the Earth seems to be moving relative to us.
Right, but none of this again. So this is just playing a game. So you're looking at it from Mars. So we already know, well, okay, Mars is rotating. Let's just forget about all this nonsense and just say, what's its relative motion to the Earth? Because that's the only motion that matters if that's what it's going to hit. So again, they just unnecessarily complicate things. You can't change the function, what actually happens based on your perspective and how far you are from something. So, we already know that about sound. Sound can bounce off of things. It can do lots of things to fool us, echoes, lots of things. So why play a game that we can't understand that? And we actually think the thing happened 17 times because it echoed 17 times? Bullshit. We're smart enough to figure it out.
Except the object is moving in the opposite direction to the Earth. So to us, from Mars, it looks like the object is not moving at all. So from Mars we would say, well, the object has no kinetic energy at all because to us it's not moving. Whereas our friends on Earth...
So it doesn't matter whether the spaceship hits the hydrogen atom or the hydrogen atom hits the spaceship. It doesn't matter who has the real velocity, because all that's going to matter is the differential between the two objects that have contact. And that's all you have to know. What's the condition relative to each other between the things that are going to interact, and that's all that matters. You don't have to do this perspective crap and try to figure out what it looks like from Alpha Centauri. It doesn't matter what it looks like from Alpha Centauri. It's irrelevant.
Earth would say, what nonsense, of course the object is moving along the ground, so it has kinetic energy. Who is correct? The answer is that both perspectives are right.
Nah, it's bullshit. So again, this framing crap has nothing to do with the notion of energy, which is again always based on the fact that the motion is always relative to the things involved in interacting. And if the motion doesn't cause an interaction, there's nothing to see here. There's no reason to pay attention.
From our point of view, or our reference frame, the object has no kinetic energy. From the Earth's reference frame, the object does have a lot of kinetic energy. But how can this be possible? Well, it's important to note that the kinetic energy of an object does indeed depend on the object's mass and speed, as we've already discussed, but in reality, the
only thing that matters is the difference between the two conditions that are going to interact. That's all that matters. That's the definition of the amount of energy differential between the two objects. That's all that matters.
value of any energy doesn't really matter. What really matters is how this energy changes. For example...
Okay, good enough. And the only way it changes is through interaction. It doesn't change spontaneous or in some way without there being an interaction. It has to be an interaction, Newton's first law.
Increases in kinetic energy or changes to other forms of energy like gravitational potential.
Well, so there's no other form of energy, and so he just talked about something changing into gravitational potential energy, which is, again, nonsense. Gravity's an active force. You stick something in a river, it moves with the river. You stick something in gravity, it moves with the river of gravity. The deficit in the amount of energy coming out of the Earth versus the energy coming into the Earth, and there's always a deficit. The external universe pushes in first. It takes time for the energy to get through the Earth, so the other side is always behind.
Energy.
If you have a child...
Oh, that's too bad. Alright, level 4, he said.
Up until now, we've been dealing with nice, friendly Newtonian physics.
No, you haven't. It's not Newton's physics, okay? Newton's physics is frickin' momentum. Newton said it right under the second law. Twice the force, twice the motion. 3 times the force, 3 times the motion. No squared velocity function. So again, I mean, you really feel okay. You don't really mind slandering what could be called one of the greatest scientists in the history of humankind. And you just don't mind putting crap in his mouth. You don't mind doing that. Because that's what you're doing. It's not his physics. His physics was not 1/2 mv squared. It wasn't mv squared. It wasn't his physics. It's not what he argued in defense of. It's what him and his surrogates spent 30 years arguing against.
This means we're assuming that Newton's laws of motion made up the correct description of the universe. But we can now switch to thinking about kinetic energy in the framework of special relativity.
So there's no point, right? So this is almost like, why bother? Because special relativity has nothing to do with momentum versus kinetic energy. And it clearly has nothing to do with any commonly moving object. So again, we know none of this time dilation, space warping crap has anything to do with anything moving common speeds.
This is one of two theories of relativity developed by many important scientists, but most famously Albert Einstein. It assumes something is true about our universe that is not immediately obvious to us. Let's imagine...
I don't even know what that means, but frankly, it doesn't assume anything we didn't already know. All it is the inverse square law. And all Einstein's saying is a bent space did it. Where in the case of light coming off a light bulb, you say, well, the electricity is doing it. It's jiggling the atoms, and when the atoms jiggle, they push the force and they create photons. It's the same inverse square law. The light comes from the light bulb at exactly the same inverse square law, the spreading in two directions. And the only difference is the light's coming out instead of going in. Gravity is just the same thing in reverse. So let's not say we don't understand the concept and somehow Einstein gave us a great explanation. All he said was invisible man did it. You might as well have said hobgoblin or gremlin or angel, because it's just as meaningless. Bent nothing. What's bent nothing got? That's like speed. It's different than velocity. This is another point where you just say, this was a satisfactory answer to you? You spent years studying this stuff and this is a satisfactory answer. Bent nothing. Makes things happen. Bent nothing. Twist the knobs. Bent nothing did it. I'm amazed that this is good enough for people with any kind of IQ. You know, something higher than a lizard. I just can't believe you people are so confident about such mush. Such mushy. This is your description. Bent nothing. That did it.
We're watching a car driving past us, and the driver throws out a ball. What speed do we measure the ball to be moving?
Right, so this is the simple argument that matter can have motion in 3 actual dimensions at the same time. A piece of matter can be going up, it can be going forward, and it can be going right. It can be doing all 3 at the same time. It can't be going right and left at the same time, and it can't be going up and down at the same time, but it can be going one direction in the 3 dimensions at the same time. Energy can't. A photon can't do that. A photon only is a one-dimensional object. It can't have 2 velocities.
Moving at? Well, we would measure it as moving at the speed of the car plus the speed at which the driver threw the ball. But special relativity assumes that this isn't exactly how the world works. The velocity of the...
I'm saying that bullshit, it doesn't. It's exactly what it says, exactly how it works. Okay, the only place you're saying this changes is somehow in photons. That somehow photons aren't matter. Well, guess what? I agree. They're not the same thing as an electron and proton. Electron and proton, you can give it 3-dimensional motion. You can't give a photon 3 dimensions of motion.
The ball, as seen from the ground, is very slightly different to the sum of the velocities of the throw and of the car.
So we know it's really not. So that's just bullshit. There's no evidence that a material object thrown isn't going to gain both velocities and retain them, especially throwing it sideways out the window. There's no way to say it's something other than the hypotenuse, okay, of that triangle will decide the rate at which the ball achieves a destination.
This effect is the most important with light, where relativity says that everyone will measure light to be moving.
Alright, so they can't do evidence for this one, right? So this is the light clock where they claim the light bounces off the mirror by traveling a diagonal line. So you shot the light this way, and somehow magically the light traveled a diagonal line, which it didn't do. all right, and a diagonal in this direction, okay, which it didn't do. You moved the side, you moved the target. The light went straight across, okay? The light wasn't fooled. The light didn't travel any second path. It didn't move down. It didn't literally do any of that. The spaceship moved away from the photons. I mean, frankly, I'm shooting the light this way, and I moved this over here. The light didn't bend. So again, they're too stupid to understand their perception is fooled. That if they could actually, create a laser beam and they could make enough distance where they could actually see the bending, and they're going fast enough to actually see the illusion that the spaceship is moving and the light is hitting behind the target because they're moving with the target and the light's left behind, that they still couldn't understand that, no, the light traveled dead straight. And the only thing that changed is the spaceship's in the way. If the spaceship didn't exist, the light would have gone straight through the ship and right over to here in a straight line. The ship is irrelevant. So let's take the ship out and say the ship doesn't have anything to do with it. I'm going to shoot a photon from point A to point B. And I'm going to be in a spaceship moving. It's going to look like the light bent. But I know it didn't bend. I'm moving away from the objects. Now, it's just so ridiculous that people fall for this crap.
At the same speed. So if the car were to shine a flashlight out the front, we would not measure the light from it to be moving at the speed of light plus the speed of the car.
Right, because the forces can't acquire any extra velocity. They're always moving one speed, and the only time they change is when they're actually pushing a piece of matter. But the fact is that when that piece of matter pushes into the universe, the force will hit it at a new location. And that means it's going to compress it and increase the frequency and all that kind of crap. But it can't change the speed. It can only change its direction. Direction changes are for free. Okay, period. But you can never change the speed. So all the light, either reflected light or produced light, is always just going the speed of light. Absolutely. It doesn't have any other choice. And you can move with it in the same direction. If I could go half the speed of light and move with a photon, then I would see the light progress slower, but I'm moving towards the target. So the point is it's going to look the same to me because the fact is I'm moving towards the target. Yeah, it's just ridiculous.
We just measure it as moving at the speed of light, but so would the driver of the car. In order for this to be possible, different reference frames have to perceive space and time differently.
There's no such thing. 3 solid dimensions of distance and space, and time is the same everywhere. The clock's ticking the same everywhere in space. It's just such bullshit.
A really strange idea if you've never seen it before, so I'll leave some stuff in the description below if you want to find out more.
Oh, how exciting.
But as a result of these interesting assumptions about the universe, special relativity deals with kinetic energy in a slightly different way to Newtonian physics.
So now he's going to tell us how this crap is relevant.
You may be familiar with the equation E is equal to mc squared.
Yeah, a piece of crap. Okay, so the only thing that's correct about it is the idea that in space there's a lot of energy, and any piece of matter is occupying part of the space the energy would have to freely fly through, and it can't do that with the matter occupying the space. So the more matter I put in the space, the more things the piece of energy will interact with, and therefore technically, okay, in a sense, the mass will consume the energy because now the thing can't get to where it was going as fast. The future gets delayed because every time it hits the matter and pushes it, it moves slower than the speed of light. And so it keeps losing energy in a sense. So matter consumes the energy that's moving the speed of light. That's the connection between these things. But there's no absolute truth that mass itself, like an electron, has any energy. It only has the energy of its proximity to other objects, like other electrons and other protons. Without that proximity, it has no energy.
which tells us that in relativity, the energy that any object has is equal to its mass multiplied by the square of...
If I could guarantee, okay, if I could shot an electron to the moon, the idea is that all of its energy will be absorbed and it will just stop, and then it will start figuring out what's the closest charged object. So wherever the closest protons are, it'll tend to move in that direction. But you'll start to steal all of its motional energy and reduce it to nothing, because the force balances through drag.
The speed of light. But this expression is only part of the story. The equation E is equal to mc squared only applies to objects at rest in our reference frame.
So again, this is more crap about a rest that you can never measure, so what's the point in it? There's no point. We don't know what's at rest. So why even bring it up? And it's always just about the relative difference between two objects that are going to interact. That's the energy.
If the object is moving, then this is the full equation we need to use. P is the momentum of the object, which is related to its velocity, c is the speed of light, and m is its mass when it was at rest.
So absolute crap again. C to the fourth. And now we're square rooting it, so we're getting rid of all the squares and keeping the c squared, so it doesn't mean anything.
For a quick exercise, see if you can prove how to get to E is equal to mc squared from this equation. But the
I would just cross out all the 2's, get rid of the square root, and keep the 4 as a 2. There, I did it. Oh, shit.
The reason this equation is brought up at all is because this expression can be used to work out...
Exactly. You can manipulate this pile of crap to say something, one of these things equals some other wacky thing that you're going to claim it equals when it really doesn't.
The relativistic kinetic energy of an object. And we'll also see a link to the classical 1/2 mv squared equation pretty shortly. The logic we'll use here is that in relativity, an object has some amount of energy even if it is at rest compared to us.
Right, so says you. So again, you're never going to tell me that I can't. Again, if I could shoot an electron and there were no other charges in the universe, okay, just the force, then the electron will stop and have no energy. It will happen.
Then, when it's moving, it has this amount of energy. So the kinetic energy it has is simply the energy it has gained because it started moving. This gain in energy is equal to the energy while moving minus the energy while it was stationary. Now, when the object is...
Again, so there's no idea of stationary, so that can never be anything you can find its stationariness. So why even play with this nonsense?
Is moving fairly slowly, meaning much more slowly than the speed of light, we can use what is known as the binomial approximation just to make the maths a little bit less busy.
Yeah, right. So they can just do like normalization. They'll just pretend the broken math isn't broken.
Again, if you want to know more, then links in the description below. But when we expand out these brackets, we see that there are lots of terms that we haven't yet written. Infinitely many, in fact, that get smaller and smaller in size. Now this mc squared here cancels with this minus mc squared, and thus the biggest and most important term in the kinetic energy of our relativistic particle is this one. But if we were working in...
yeah, whatever. You got two masses in there, which is a little funny. But anyway.
Classical physics, we could rewrite the kinetic energy in terms of the particle's momentum rather than just in terms of its mass and velocity. And if we were to do that, we would get this expression.
Why? So I don't even understand that. We could write it some other way. It's mv. Well, energy equals mv. It's done. You don't need this. so again, just nonsense. So P has an M in it, right? So I'm just saying, isn't that kind of weird? You're dividing by mass, so you're just taking the mass out.
Exactly the same. This is one way of understanding where the factor of 1/2 comes from. And we can see that the relativistic kinetic energy is an infinite set of terms that get smaller and smaller, thus correcting to the actual energy by smaller and smaller.
So none of that crap happens in anything we physically have ever seen as an experiment. So again, all of this nonsense, this minutia, doesn't have anything to do with anything real.
amounts. And the classical kinetic energy is just the first, biggest term in the approximation.
It's the only term in things going less than 300,000 miles an hour or something. I mean, none of this will mean anything unless you're going at speeds we can't achieve.
This is your brain when you're...
Shit. So
I've seen a fairly intense treatment of kinetic energy. Things definitely get way more involved and complicated than this, but for level 5, I wanted to introduce a few ideas that aren't necessarily mathematically difficult, but maybe conceptually difficult.
Whatever. So this is probably going to be absolute wacky, silly nonsense, right? So anyway, it hasn't been on the subject yet.
The first thing I wanted to mention in this level is that we've discussed a lot about what we've
This is level 5.
called kinetic energy so far. But in reality, we were only looking at one aspect of kinetic energy, linear kinetic energy.
So the fact is, it doesn't matter, linear or angular, it's still momentum. So it just doesn't matter. There's no such thing as a linear difference. So you're either going to square the velocity term or you're not. But there's no difference between linear and rotational. It's the same idea of an actual velocity.
This is the energy an object has due to it moving in a straight line. However, if our object was to spin or to rotate or move along a curved path, then we need to consider what's known as its rotational kinetic energy. This rotational kinetic energy, of course, depends on the speed of the object.
Yeah, it's all it is. It's just momentum. Again, it's speed. Yes, it has a velocity, period. You can measure it. The end.
Angular motion, or in other words, what angle it's covering per second. But the other quantity that the rotational kinetic energy depends on is not the mass of the object, but rather what's known as its moment of inertia.
So nonsense. There's no such thing as any inertia, and it's just about the mass. So if I put a 5 mass out here, or I put a 10 mass at half the distance, I'll end up with the same thing because it's a lever, and that's all it is. And it's going to obey the law of the lever. So it's just that simple. I mean, twice the velocity out here that there is here, halfway. That's the rule. There's nothing complicated about it. There's nothing it adds at all.
Just like how the mass of an object is a measure of how hard it is to move it along a straight line, the moment of inertia...
So again, it's not how hard it is to move. It's obviously big things need more energy to move. Gravity gives a hammer a lot of energy. It hits the ground, has a lot of energy because it collected a lot of energy because it's big. Lots of little electrons to collect the gravity. You have fewer electrons, you collect less force.
Is a measure of how hard it is to make our object rotate or move in an angular manner.
So this whole idea again of how hard it is or that the thing is resisting, there's nothing resisting motion. You just have to give it enough motion, enough water, to quench its thirst, so to speak. I mean, a big glass, you have to fill it up, it takes more water. I mean, I don't know. It's not that complicated.
It does depend on the object's mass, but also depends on the shape of the object. So, rotational kinetic energy is worth checking out if you want to find out more, links in the description. I also want to quickly discuss how kinetic energy is dealt with in quantum mechanics.
So why this is level 5, I have no idea. What's that? That wasn't anything.
In the theory of quantum mechanics, an object's kinetic energy once again looks like this when written in terms of its momentum, but the tricky thing with quantum mechanics...
Again, I still can't really understand what's the point of this because the M is in the P, and that's not a good idea.
Is that this hat above the P represents an operator. An operator is what we use to make a measurement on a system or an object that we're studying. In other words, our object does not necessarily have kinetic energy or momentum. Instead, we apply a momentum operator to our object.
Whatever. Oh, babble, 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 babble.
The difference between these two ideas is very subtle, but relativity and classical physics assume that our object just has this kinetic energy all the time, and we simply calculate it or measure it. Whereas quantum mechanics assumes that the system collapses into a state.
So we know nothing can collapse because everything's being measured all the time. And this whole idea that only when a human decides to look at the moon is energy hitting the moon or something. I mean, it's just absolute nonsense. The photons hit the moon. They're reflecting all over the place. It doesn't matter if I look at it. Something else already looked at it, so to speak. The photons looked at it. And everything is getting hit by the force. Gravity and all the other stuff. All the radio waves, all the crap is hitting everything all the time. Nothing can ever be, waiting to be de-entangled. Everything's going to be de-entangled instantly. There's no quiet place in this universe.
Of having a particular momentum or kinetic energy when we make the measurement.
So it's just absolute bullshit that has something to do with when we measure. All measurements made by all energy. Any piece of energy that has interaction with something has now measured it. It's going to now change that thing that interacted is now going to be changed by the interaction. It's going to create an effect in the universe, a change in the universe. All right, it has a history now, a very time-dependent history. Things will be interacting with it, and things will be changing in the universe based on that thing existing. And it's constantly happening. It can never stop being a changer of the force. Every object is radiating force through reflection, absorption and reflection and readmission, constantly changing what the universe would look like if there was no matter there.
At least that's how the Copenhagen interpretation
Yeah, bullshit.
of quantum mechanics deals with it. I've discussed this strange idea in more detail in this video up here, so check it out if you haven't seen it already. And this brings us to the end of the 5 levels of kinetic.
So that was just terrible. That 5th level had nothing to do with energy or kinetic energy or anything. He never mentioned momentum anywhere in this whole pile of crap about the concept of energy and why he thinks momentum isn't energy. Okay, what's the big giveaway? Where do I see the big giveaway where momentum fails to ever get a right answer? Just show me the circumstance where if I calculate the momentum, I'll get a wrong prediction about the outcome. Because I'll certainly say in the simple one, 5 mass going 10, 10 mass going 5. If I calculate the momentum, I'm going to get the right answer. You're going to get the wrong answer. You're going to get the wrong answer. You're going to say the 5 mass wins the tug of war. That's going to be your idiotic, stupid prediction. I'm going to get the right answer. You're going to get the wrong answer. It's just terrible that these cowards will not deal with the... it's just such bad reasoning. It's bad logic. It's worse than religion. Bent nothing is worse than religion. Fake, phony, bullshit squared velocities is worse than. Okay, that's worse than a King David or any of this other crap, that religion, Moses parting the Red Sea or the Reed Sea. But anyway, oh, God, I just hate this planet. Hate this shit. So none of this is ever going to get fixed. So this is another one of the guys just in the way. He's in the way of the truth because he won't address the points. And the only people who can fix the physics are the physicists. They have to clean up their act. And they won't do it. Because they're afraid, of accepting the fact that they've been duped. They don't want to believe they were fools. But it's just a fact. You were fooled. Badly. I mean, it's embarrassing that you fell for this crap. This unevidenced nonsense. Bent nothing. You accepted bent nothing as an answer. Yes, you're a fool. Fuck. Oh, anyway, till the next time and such. So I will attempt to, see if you'll watch the video, but you probably won't. These are just cowards. Despicable fucking cowards.